Hello, I am Rajendra Bade. We are going to solve some more problems on orthographic projections in this video. Now let's read this problem. Pictorial view of a machine part is shown in following figure. Draw front view in the direction of arrow X and top view. First of all, we'll identify orientation of length, width and height in this diagram. These are our regular three axes. Vertical axis is of course height axis, and out of these two inclined axes at an angle 30 degrees, width axis is that axis which is parallel to this arrow X. So we are going to check width in this direction, height of course vertical, and length in this direction. Okay, let's check length of the object. Length, that is those dimensions which are parallel to length axis. So 60 millimeters we can see here at top. It is given distance from center to center. Extreme right edge is curved edge, extreme left edge is curved edge. So we'll have to check the radius of those curved edges. So center to center distance 60 millimeters is given. Radius here it is 18 millimeters. Radius here it is 18 millimeters. So 60 plus 18 plus 18, that is overall length from extreme right to extreme left. That is length of the object. It is 60 plus 18 plus 18. It is 96 millimeters. So we have identified length of the object. Now let's check height of the object. So 90 millimeter vertical dimension is given, but it is from base, from bottom of the object, but not up to top, but up to the center of the cylinder. And topmost edge is curved edge, so we'll have to add its radius. So it's 90 plus 18, 90 plus 18, that is total height of the object is 108 millimeters. So this is how we have found out height of the object. Now total width of the object, let's check it. 24 millimeter dimension parallel to width is given. This is from extreme front. So from front to back, complete width we are checking here. So 24. So this distance from front up to the surface, this edge of the plate, it is 24. And then add 25. So 24 plus 25, that is 49. Now from extreme front, 36, that is cylinder's axis length. But that is not width of the object, it is axis length of the cylinder. Width is from extreme front end to extreme back end. So it is 24 plus 25, that is 49. This is how we have identified length of the object, height of the object and width of the object. If required, pause the video, check whether you have understood overall length, overall width and overall height of the object. And now let's proceed. So since we have identified overall dimensions of the object and we are asked to construct only front view and top view, let's start with front view rectangle. Always we start with front view rectangle, in which length horizontally, height vertically. So length 96 and height 108. Complete the rectangle. Rectangle of height 108 and length 96. Transfer that length in the top view. Project that length 96 in the top view. The other dimension appear in the top view is width vertically. And how much is that width? 49. So leave some space, approximately 20 millimeters, and then measure width 49 and complete the rectangle. So this rectangle, height 108, length 96 for front view, and this rectangle, length 96 horizontally, width 49 vertically, top view. Now check whether diagram is symmetrical. As I have told you that one glance is enough to know that whether object is symmetrical or not. This is not a symmetrical object, so there will be no any axis of symmetry for front view or top view. Okay, now we'll start constructing shape part by part. So there are two cylinders I can see here which are connected by plates. So two cylinders at top. From front, this is front direction. That means in front view, these two cylinders will appear. These are hollow cylinders. So locate center. From top at distance 18 mm, that is the radius of the object, this center line which is parallel to length. So I am drawing that center line. This center line is parallel to length axis. Length appears horizontal in the front view. So from top, measure 18 mm, that is center is at distance 18 mm from top, and then draw the center line. Now measure 18 mm. From left, center is 18 mm. Also from right, center is 18 mm. So locate those centers first. Similarly here, from right 18 mm, and I have drawn the center lines. So this is how we have located centers of these two circular edges. So this is how complete circles, and there are holes also. So draw concentric circles. So inner circles represent opening of these two holes. When depth of holes not given, we should assume through holes. So these holes are through holes. But right now in the front view, we just can see opening of the hole. Now this two cylinders will appear rectangles in the top view. And third dimension for the cylinders. For example, this cylinder. This is length of the cylinder, width of the cylinder. This is the height of the cylinder, in fact. And width of the cylinder is 30. Width in the sense dimension of the cylinder parallel to width axis. That will appear vertical in the top view. So this 36 mm dimension will appear vertical. So from front you should measure 36 vertically. So project horizontal dimension, that is draw end projectors of the cylinder. Measure 36 from front, complete the rectangle. So this is how this cylinder, that is this cylinder, is in the top view, which appears rectangle. In front view circle, in the top view rectangle, in the side view rectangle. But in this question, we are not asked to draw side view. Okay, similarly this cylinder we are completing. Then there are holes in the cylinder. So for the holes, we should draw dotted lines. So nothing new here. So this is how we have completed the two cylinders. Now where cylinder appears a rectangle, in that view we should draw axis of the cylinder. So I have drawn these two axes of each cylinder. So cylinders are over. Now let's focus on these two plates. This plate, which has certain shape. Okay, so we'll try to construct these two plates. This plate, which is vertical plate, it's this particular shape will appear in the front view. But this plate, which is 12 mm thick, it will appear as thin strip of thickness 12 mm measured vertically. So this top edge is tangent to both the circles. Then this bottom edge tangent to both the circles. And here at distance 12 mm from the lower tangent, from this lower tangent, vertically measure 12 mm and draw a thin line. Don't make that line dark at this stage, because there are curved edges here of radius 4 mm approximately. If radius of such small curves are not given, we can assume that radius. Okay, so we'll draw these two curved edges, these small curved edges here. Watch. To draw such smaller curves, you may use a pro circle. So draw those curved edges, and then the portion of the edge you should make dark. The portion which appears as horizontal edge you should make dark. So this is how we have completed this particular edge, which is 12 mm from lower tangent to the two circles. Now, yet it is not complete. When this plate is connected to the cylinder, check the joint, that is this line, and here this curved line. Check the joints. Here, these surfaces, circular surface, this ring-like surface of cylinder, this front surface, ring-like surface of the cylinder, and this strip-like surface, they are in one single plane. So these two lines should disappear here. Now let's draw this cylinder. This plate. This plate in the top view. Nothing to think. This plate appears between its end projectors. So focus on right end of this plate, left end of this plate, and draw end projectors. Between these end projectors, we are going to draw 12 millimeter thick strip. So here it is. So in front view shape, so in top view, it is rectangular strip between end projectors. But there is a mistake here. Two visible edges don't intersect. And one more thing. These two edges here, what you are watching here, are not here. The reason is, watch the three-dimensional view. The reason is this strip-like surface of the plate meets curved surfaces tangentially, and that is why there are no sharp edges here at this end and at this end, where that surface of the surface of the plate meets curved surface. At that joint there is no sharp edge. So these two edges must not be there. So I have erased those two edges. And watch these small curves here. These small curves, diagrammatical representation that indicates tangential joint between two surfaces. So when a flat surface meets curved surface tangentially, then in orthographic views, this is how we denote that tangential joint. And that edge, sharp edge, which I erased here just now, is replaced by this curve, indicating it is not a sharp edge here, but it is tangential joint. So this is how we have corrected the joints here. Now one more thing, these two edges are also to be erased. I have erased edges here, check here, and here also. So necessary correction you will have to do. Remember, when two surfaces meet in one single plane, then boundary between the two surfaces you will have to trim out. So curved surface of the cylinder. Remember, this is this dark line. Can you see here? This dark line. This is boundary generator of the cylinder. So cylinder has a 36 mm long boundary generator at extreme end. Yes. But inside here, the boundary generator is not 36 mm long. The curved surface is not 36 mm. It is 36 minus 12. That is why this portion is to be erased. Remember this, two visible edges intersecting, that suggests you some correction. And remember, on the boundary generator, when there is a joint on boundary generator of a cylinder, if joint appears, then boundary of the cylinder inside the joint is to be erased. Now this horizontal plate in the top view, you will have to complete by drawing a dark line here. So this surface, what you are watching here, horizontal surface, you can see here. So this is how the upper portion is complete. Now this lower part, let's complete. Check here. I've just separated from the upper portion that lower portion. Here there is a hole. The smaller detailed holes and slot we draw afterwards. Now how to complete views of this? So this F-like shape, this F shape, inverted letter F shape, it appears in the side view. So in front view and in top view, this object appears a rectangle. So let's complete front view of this object. Which two dimensions you can see in the front view? Height and length. So check what is height of this object. This object is attached to the upper portion from lower side. So 18 mm from 90, you subtract 18 mm, that is radius of this circle. So it's 72 mm, that is height of this. Of course, you need not measure that 70 mm. Extreme bottom to the upper portion, you can draw those lines. And length of this, the length in the sense parallel to length dimension of this object is 60 mm. So 60 mm length and 72 mm height. This portion is complete. When you measure 72 mm, the part will get connected with the upper portion. So this rectangle is front view of this portion. But of course not yet complete. We have just measured height and length. In the top view, the same portion will come. Length 60 millimeter we have already measured here. 60 millimeter length we have already measured here. Now project it downwards. And width of the object is 25, but that is from extreme back side. So from back 25 you should measure. And this is how we have completed the rectangle in the top view. Now this is very important to understand. Check carefully what I am telling you. Front view of the lower portion of the object, this portion of the object. Front view, length 60, height 72. This is front view. And front view of upper portion, there is no overlap here. Front view of lower portion, front view of upper portion, no overlap. But in this case, top view of upper portion and top view of that lower portion, there is certain overlap. The box, this F-shaped portion we are drawing here is under the upper portion, and the portion which is overlapping, that is hidden. So when you complete this rectangle, you will have to take care of that. So watch here, this portion we have drawn visible, which is not overlapped, and this portion is hidden. So where is this part in the top view? So again, show me this complete rectangle. Each and every part in each and every view you must be able to identify. Then only you will able to read orthographic views properly, or you will able to construct orthographic views properly. This is that lower portion. Okay, now smaller details. Let's continue with the smaller details. A corner is formed by 3 edges. Here, from each of these corners, watch these corners. There are edges you can see running from right side to left side. Watch here, these edges are running from right side to left side. So right side to left side, that is parallel to length. So we are going to draw those edges here. Measure 12 millimeters from bottom. Draw that hidden line. From front, these edges are hidden. 25 millimeters I have measured. Draw the hidden line. And 12 millimeters again I have measured and hidden line. These edges are parallel to length axis. Okay. So this is how front view, except this whole front view of the object is complete here. Now in the top view, same 3 edges. So these edges we are drawing here in the top view will overlap with already drawn edges. And that is why these 3 edges or the edges from these corners will not appear in the top view. Not appear in the sense they are already overlapped in the earlier drawn edges. Okay, now let's complete this hole here. This hole has certain shape, so we'll have to construct the shape very carefully. So measure 25 millimeter vertically and draw the center line which is parallel to length axis. So 25 millimeter vertically I have measured, and this center line which is parallel to length axis. Now watch this dimension 22 millimeters parallel to length. So measure 22 millimeters parallel to length and draw the first center line here, which is vertical center line. And then at distance 9 millimeter, watch here, 9 millimeter. At distance 9 millimeter to be measured parallel to length again. One more center line. So this is how we have drawn those 2 center lines which we can see here to draw those curved edges, and the radius of each curved edge is 8 millimeters. So draw those semicircular edges here with radius 8 millimeters. And then complete the shape by small principal edges here, parallel to length edges. So this whole opening in the front view is complete. Now draw end projectors from the hole. This hole is in this 12 millimeter thick part only. 12 millimeter thick part only. So draw corresponding dotted line. So this is how that hole is complete in the top view. One more part is remaining. That is this triangular plate. I have separated the triangular plate. Now its triangular, largest surface, that is triangular portion, is visible in the side view. We are not asked to draw side view here. But In the front and in the top, since it is a plate, it will appear a thin strip showing its thickness. Thickness is 12 millimeters, which is parallel to length axis. So thickness 12 millimeter parallel to length to be measured here. In the front view, it is a strip from bottom, and in the top view, it is again a strip, but it is under the upper portion of the object. So this strip is hidden in the top view. So check, I am drawing this triangular plate in the front view. That's all. It is rectangular strip of thickness 12 millimeters. So measure 12 millimeter thickness of the plate, which appears parallel to length axis. And in front view, length axis is horizontal. So this is how I have completed the triangular plate in the front view. Now same plate in the top view. Draw end projectors and up to this part. Watch here. This rectangle is the same triangular plate in the top view. So even if there are so many hidden lines, you are not confused. You know that these two hidden lines here for the hole, this hidden rectangle is for the triangular plate, and these two hidden lines for the circular hole, this oval shaped hole. So if such orthographic views are in front of you, so take help of end projectors. Imagine, visualize end projectors to read the orthographic views. Right now we are not reading orthographic views, we are drawing orthographic views from given isometric view. Okay, let's proceed now. Insert all given dimensions, and which method of projection we have used here? First angle method of projection. Okay. Remember this again. In between the views, as far as possible, we don't insert dimensions. But as I have told you, the given dimensions must be nearer to the corresponding feature. So instead of drawing very long extension lines, it's better to insert these dimensions in between the views. Insert for entire hole diameter, and for portion of a circle radius. Take care of that. Enough space between parallel dimension lines. So follow all the rules of dimensioning, complete the dimension, and your drawing will be perfect. So thank you for watching the video. We'll meet soon in my next video. We'll continue with orthographic projections. Till then, bye bye. Take care.